Find the equation in standard form for the line that satisfies the given conditions. Perpendicular to the line 3x minus 2y equals 4 and has the same y-intercept as 5x plus 4y equals 12. To find the perpendicular slope, we'll need to isolate y, adding a negative 3x to both sides of the equation. We get negative 2y is equal to negative 3x plus 4. Still need to get y alone. We multiply both sides of the equation by negative 1/2. On this side, since there are two terms, we're going to use the parentheses. This negative 1/2 gets multiplied to the negative 3x, giving you positive 3/2 x. And this negative 1/2 multiplied to the 4 gives you a negative 2. So our slope for this line is 3/2. The slope we want to use is the opposite reciprocal, negative 2/3. We also need the y-intercept from this equation. So again, let's get y alone, or better yet, let's just find that y-intercept by allowing the x value to be 0 and then solving for y. If 4y is equal to 12 and multiplying both sides of the equation by 1/4, we get y equals 3. Let's recall that slope-intercept form, y equals mx plus b, and plug in these values, 3 for b and negative 2/3 for m. Magically, it's there. Okay, now we're going to put this into standard form, which means the variables need to be on the same side of the equation. So we need to add a positive 2/3 x to both sides of the equation. And we have 2/3 x plus y is equal to 3. This is still not yet in standard form because we have a fraction as a coefficient and they need to be integers, positive integers for the coefficient of x. So I can multiply each term, each side of the equation by 3, but since there are two terms on this one side, they're both going to get multiplied by 3, and reduce. We have our final answer for the equation perpendicular to the first line with the y-intercept the same as the second line, 2x plus 3y is equal to 3 times 3 is 9. So that is the equation of the line perpendicular to 3x minus 2y equals 4 and has the same y-intercept as the 5x plus 4y equals 12.